Hello, welcome. In this short video, we are going to see the importance of average value. My name is Durgesh Kusuru. So before we start, let us see the difference between electrical versus electronics. So if you consider the phenomena like electrical machines, electrical power generation, transformers, and the distribution of electrical energy, so they fall in the category of high power but low frequency. If you take an example here, so this railway power line so will carry the high voltage, right, but with low frequency. So therefore this will fall in the category of high power but low frequency. So whereas if you go to the modern systems like mobile communication, radars, satellites, optical fibers, they fall in the category of low power but high frequency. For example, if you consider this optical fiber, so it will use the frequency in the range of terahertz. So whereas the power utilized is very few watts, 5 to 10 watts. So therefore, this is the main difference between electrical versus electronics. So why average value is very important? This is very important because it tells us the overall DC level of a signal which varies over time. And this DC value is very useful so in many electrical and electronic systems, right? So many signals vary with time. So those signals we call it as the AC signals. The average value shows whether the signal has DC component or not. Right? For example, if you talk about, if you take an example like pure sinusoidal signal, so over a full cycle, the average value comes out to be zero. So what is the meaning of this? So meaning is that there is no DC component. So if you take an example in electronic systems like rectifiers, we generally prefer a higher average value. So because what we need, what we want the output of this rectifier is the DC output, right? So if you consider in AC power transmission, so the average value is zero and not that much important. So what is important is RMS value. So this is used to measure the power. Okay, so therefore as far as the power transmission is concerned, so the important value is RMS value, so which is used to determine the power delivery. So let us take an example how this is how the DC value is useful in rectifiers. So the main the goal of this rectifier, this is a rectifier, let us call this is a rectifier. The input will be, the input for this will be AC signal. This is the AC signal, input is AC. So what we expect is the DC, but here the output will be so the pulsating DC. For example, if you consider a full wave rectifier, which will be looking like this, the output will be looking like this, right? So therefore, this is called the pulsating DC, right? So in this particular output, so what we need to find is, so what is the overall DC in this particular pulsating DC. So this is AC plus DC, and what is the main goal is we need to get DC, but here we have AC plus DC, so we need to find what is the content of DC in this AC. So for that we need to calculate the DC value, right? So the applications are battery charges, the power supply circuits, and adapters. Suppose let us consider the rectifier. The output of the rectifier is this. This is the output of the rectifier, which will have both DC as well as AC. Now the question is, we need to find the power of DC as well as AC, right? So for that we need VDC into IDC plus AC power, correct? So what we need here is we need to find what is called efficiency. So if you talk about the efficiency of the rectifiers, so the efficiency is nothing but out of total AC power, how much power is converted to DC. So that is nothing but efficiency, right? The main objective of the rectifier is to get the DC output power, right? So with the input as AC. So therefore, so in order to calculate that, we need to calculate the efficiency, which is nothing but PDC by PAC into 100. So to calculate this PDC, we need VDC into IDC. So therefore, so these two are DC, are average values, average values. So therefore, in order to find this, we need to use the average value. So the typical efficiency values, if you consider the off-air rectifier, it comes out to be approximately say 41%, and whereas the full wave rectifier it is approximately 81%. So what is the meaning here is that so 81% of AC power is converted into DC. So therefore, so the efficiency of full wave rectifier is much better compared to the half wave rectifier. And not only this, so this is used in many measuring instruments. So these are the two examples. So where the DC or the average value is very important. So these are the two examples where the average value is very important. So with this, we'll stop the video here. In the next video, we'll come up with how to calculate the average value. So what is the formula, and we'll see problems. So how to calculate average value for a given signal. Okay. So till then, take care. Thank you.